Hello, Professor Sargent here with you again. I have here a response to a video that Cybermath made within the past year or two, and he was looking to see if anyone viewing and commenting could come up with other solutions than the two solutions that he came up with. I commented within the past year or two, and someone said it was a nice solution, and I asked if I should film it. I didn't want to steal Cybermath's examples. In the past month or two, he responded and said that it was okay. So I am proceeding with his blessing. I'm going to show two methods as well. My first method is a longer one, but in the end is related to one of the methods that he showed. Then I'm going to show the method that I typed up in the comments. First method, I'm going to use the binomial theorem. First rewriting 33 as 32 plus 1, since that was being raised to the fifth power, and 32 is 2 to the fifth power. Then by the binomial theorem, we would have that 33 to the fifth is equal to the following. It's going to take a little while to write this. There we go. And I'm going to use the property of exponents that when two exponents are right next to each other, then we multiply the exponents. I want you to pay attention to the 2 to the 25th there and the 2 to the 15th. It's going to be involved in a comparison shortly. Do something similar for 63 to the 4th. Express 63 as 64 minus 1, and 64 is 2 to the 6th. Now apply the binomial theorem again. And similarly apply our property of exponents, that when two exponents are right next to each other, we multiply the exponents. However, 33 to the 5th and 63 to the 4th compare when you add the same thing to both sides of an equation or of an inequality, whether greater than or less than. It's not going to change what you have in terms of the comparison: equal, greater than, less than. So I'm going to add 4 times 2 to the 18th plus 4 times 2 to the 6th and subtract 1. That way, the first part that I had, we would have the following. We've added a negative 1, i.e. subtracted 1, and we're adding the 4 times 2 to the 18th and the 4 times 2 to the 6th. We were comparing what I had right here to this, and I have added what was being subtracted. I've added that to both sides and subtracted 1 from both sides so that we're getting these 1s to cancel out. So that on the second one, we're left with the following. Well, the function y equals 2 to the x is increasing, which means that if you have b greater than a, then 2 to the b is greater than 2 to the a. And that is being applied with 2 to the 25th being greater than 2 to the 24th, here versus here. And 10 is greater than 6. It's a positive. So 10 times 2 to the 15th is greater than 6 times 2 to the 15th. And applying what was just stated about y equals 2 to the x being an increasing function, that is greater than 6 times 2 to the 12th. Everything else that we have that I have not underlined in this portion here is something positive. So already I've shown 2 of the terms in the first one, their sum being greater than the sum of the 2 terms that I have in the second one. And I'm just adding on larger positive numbers to that. So that is giving us that we have 2 to the 25th plus 5 times 2 to the 20th plus 10 times 2 to the 15th plus 10 times 2 to the 10th plus 5 times 2 to the 5th plus 4 times 2 to the 18th plus 4 times 2 to the 6th is greater than 2 to the 24th plus 6 times 2 to the 12th. So if I went backwards, that would not change any of the reasoning. I could subtract from both sides 4 times 2 to the 18th and 4 times 2 to the 6th and add 1 to both sides, and I would still have that inequality going in the same direction. Therefore, we have found that 33 to the 5th is greater than 63 to the 4th power. So what about our second approach? First of all, keep in mind that, all right, I want to compare powers of 33 and 63. Well, before I talk about 63, let's talk about something nearby, 66. Whether you view this as a fraction or as division, since the denominator is the same, but the numerator on the left is greater than the numerator on the right, we have the following fact. And 63 over 33, of course, reduces to 2. Whereas over on the right-hand side, we're looking at the 2 bases that we were interested in. Now, because the numerator is greater than the denominator, then this is greater than 1. Why is that important? Think about graphs of things like y equals x squared, y equals x cubed, so on. When what you put in for x is greater than 1, then when you raise it to a power, you're going to get something greater than what you started with. So that's going to be greater than 1. Therefore, 2 to the 4th is greater than 63 over 33 to the 4th power. 2 to the 4th is equal to 16. "33 is greater than 16. So we have that 33 is greater than 63 over 33 to the 4th power, which is equal to 63 to the 4th power over 33 to the 4th power. And if I multiply both sides by that positive number, 33 to the 4th power, add the exponent of 1 that was not originally written there, and that's going to be greater than 63 to the 4th power. That's a much shorter solution. There's one or two other trains of thought I've been following, but I have not completely fleshed those out. So I'm going to leave it at just these two methods. And I hope that helps to give you some more ways of looking at things. CyberMath did a great job, and we have some additional thoughts here now. Take care, stay healthy, see you in the next one.